Hi guys, welcome to my second episode of learning functional programming with Clojure. Today I'm going to be continuing my online course that I started. We ended up at this chapter. It was about if statements and expressions and stuff like that. I finished it. So we will be moving on to structured data, where we will be learning about local names, data structures like vectors, maps, sets, and abstract sequences like mapping and filtering. And since this is a pretty long segment, as you can see, it has 34 exercises, but so it doesn't matter. I will try to do it all in this video. Let's see. I also, as you can see from the previous episode, I switched from my Ubuntu installation of VirtualBox, and I moved on to Arch Linux. I messed around over the weekend configuring it, and it worked out pretty well. I also managed to install Lighttable, as you can see, the Clojure IDE, which I will be using now for coding up the Clojure code. So we should get started. I already forked the project, structured data. As you can see, we have all these undefined functions that we will probably have to solve. So let's get started. So the first thing we will get to know is the keyword let. A function or a value that is needed only inside one function can be given a local name with let. Okay. So for an example, they give us a function that calculates the hypotenuse. I don't know if I'm pronouncing that right, but it's the side from the Pythagoras theorem. Basically, you just take x squared plus y squared, and you then under the root. So you basically define with let, you define that xx equals to x times x and y equals to y times y, and then you just call the function math sqrt on plus xx yy. You basically call x squared plus y squared, and you then just square root them. So here we have an example of how let works. So let, and then you define a name and then a value for that name. Okay. So they tell us that the let names are not visible outside the expressions, so they are only visible inside these parentheses. So if we tried to use the x that was defined here outside, we will get an error, so unable to resolve this symbol. Okay, so exercise 1, if it would be this, fill this. Okay, so the exercise 1, we have to do a thing. So change the function do a thing so that it uses let to give a name to the common expression plus xx in this body. So what we do, okay, so if I understood correctly, we use the let keyword like this. We do let, and then brackets, and we do, let's just do XX and is plus XX like this. Like this, and then we just have to math. So we oops, in trouble. Okay, so we do a math to the power of XX. So I think this should work. Let me just open my terminal window like this. Okay, so let me change directories, structured data, and let's run our tests. So everything, I think we implemented this method correctly, at least I hope so. The tests take pretty long to run as usual, so let's check at the start if the tests for this haven't passed. So it seems that they have, because we don't get an error for this function. We get an error starting with this, so I think this is implemented correctly. So that's great. Just clear the screen. Okay. Okay, so let's go forward. So the names declared in the let expression can refer to previous names in the same expression. So yeah, we already saw that when we declared this XX, we could refer to it here. Okay, let's look some to the values that Clojure supports. We have numbers, we have real number, we have numbers, simple, we have fractions and floats, we have strings, which is a text value, we have a single character written with a preceding backwards slash, and we have keywords used in map keys, and we have two Boolean values. Okay, so now vectors. Collections are the other kind of values in addition to scalars that are crucial to programming. Okay, a vector is a collection that can be indexed with integer like an array in other languages. Okay, so we can imagine vectors as an array because it's indexed with integers. So the first element is at index 0, second one at 1, and so forward. But I guess the difference is that you don't have to have the same type. You can have a keyword, a number, string, expressions, and it doesn't matter to the vector. It can be all stored in the same one. So a vector is written with surrounding brackets, and the elements are written separated by white space and optionally with commas. So if we write get and then a vector and then a index, we get that index. So it's basically the same as accessing an array. So and the other thing that's different, we don't get an array out of bounds exception like we do in Java when we try to access a field in an array that is out of its bounds. Like if we have an array of size 10 and we want index 15, we would get an exception. Here Clojure just returns the key value nil or null in Java. Okay, so we're right here at the second exercise. So write the function spiff that takes a vector and returns the sum of the first and third elements of the vectors. What happens when you pass in a vector that is too short? Well, I guess we'll have to find out. So we just have to add our the first and the third. So the elements at indexes 0 and 2, if I got that correctly. So we do a plus get our vector v and 0, and then we have to do a get v2 like this. So let's try and run our tests, see if it passes or if there will be some problems with functions like these where we don't have enough elements. So tests will run. Let's scroll up. Whoa, where are you? I lost it. Damn. Where are you? I should just run it again because I won't find it. But it 5 succeeded, so I guess some of them were correct, but not all of them. So let's go slowly this time. Oh, here we are. So no, I guess they run correctly. At any errors for our spiff function. So I guess that's all right. Okay, let's go forward on basic vector operations. Yay. So vectors are immutable. Once you have a vector, you cannot change it. You can, however, easily create new vectors based on a single vector. So conj adds a value to a collection. Okay, to be exact. So yeah, it's immutable, so it does not change, but it returns a new vector. Okay, so write the function codify v that takes a vector as a parameter and adds a heart to its end. Okay, so we have a vector v, and we should probably use the conj keyword. So if we do conj v and string like this, that should work, I guess. So let's run our tests. Okay, I saw that we had some tests pass, so let's see if there are any problems. Nope, I guess we got it right the first time. Okay, so vectors, a postmodern deconstruction. Sounds fancy. Okay, another way of extracting values from a vector is by destructuring it. Oh, so here we basically map x, y, and z to the first three values. So 1, 2, and 3. Okay, so rewrite our earlier function space by destructuring its parameter. Call this new function space destructuring. So we have to rewrite this function. Oh, so we basically do this. Okay, so we start with a let, and then we need a couple of brackets like this, or we just have v here and x, y, and z here like this, and oh, we need a closing bracket. Okay, and once we have this, we can just add the x and z, so plus x z. Okay, I think that should work, but I'm not gonna run the tests again because it takes some time, and if anything's wrong, we'll just correct it later. Okay, moving on. You can destructure function parameters directly. For an example, take the following function. So let's see. Define some pairs, first pair, second pair. Okay. Okay, the function takes two vectors and sums the elements pairwise. Right. Okay, so right, we can. All right, we're just structuring the function parameters directly, or right, like we were doing in this exercise 4, we can do with the function parameters directly. I guess I kind of understand it. Okay, let's go on. Thinking with boxes. Let's define a simple representation of a two-dimensional point. It will simply be a pair, two-element vector of two numbers. So we get define point x and y. Okay, and the representation of the rectangle will simply be a pair of points, the first being the bottom left corner and the second being the top left corner. Okay, let's just do the exercises. Write the functions height rectangle and width rectangle that return the height of the given rectangle. Okay, try and do that. Right, so for the height function, we just have to destructure both of the x values and subtract them. And for the width, we just have to destructure the y values or wait, no. I think I might be getting that wrong. So if we want to so this is the bottom left point. Yeah, and this is the top right point, and we need to get the height of this rectangle. So if this is xy and this is xy, so how to get the height of the rectangle? We just need to, for the height, we just need to subtract this 5 minus 1, and the height is 4. And yeah, since I think I might be getting that backwards because I think I'm getting that backwards. Yeah, I guess me and this exercise have the height and width mixed up. So let's just try and code this. So we'll need some refactoring, or I mean, how, how do you say it? Destructuring, yeah, like that. So let's try and do that. I guess this isn't as easy as it seems. I just need to figure out how to destructure this. So I guess I should be using this. When you have nested, maybe I should just go over the exercise again. So we have a point, this, which basically just returns itself, I guess, and the representation for a rectangle, bottom left, which is a point, and a top right, which is a point. Like this, we basically just give them, we call a function rectangle and we give it a vector of 1, 1 and a vector of 5, 1. And then we just call a rectangle function on that. And then we call a height function on that. Okay, so I think I should just copy this and try my luck with this. Okay, so do something with the coordinates. So if we're doing height, we should subtract, we should do minus x2 and x1. Now I'm really wondering if this works, so let me run our test command like this. Oh, that did not work. So unable to where? Structured data, I think that's line. Oh yeah, that's my bad. I think I should be actually moving this inside of these parentheses like this. I think that's gonna work. Let's try again. Right. Okay, so now it ran. So let's see. Okay, only 119 checks failed, but 12 succeeded. So let's look on the bright side. So let's see if our height function actually worked. A bit of scrolling again. Okay. Okay, it did, as I'm seeing. Oh, it didn't actually. So we're actually not doing something correctly. So maybe I should just run on the REPL. So I guess go to, nope, not this, but I guess, nope, not even this. View, edit. Let me just find the REPL somewhere. Insta REPL, okay, got it. So, but I don't see it anywhere. Try it again. Only works for Clojure, but I'm using Clojure. Okay, let's just run it here. So lane REPL like this, and we'll do our best. But let's just take a look at what we're doing wrong. So I think that should be working because use structured data. Okay, not found. I misspelled. Well, I don't know what's wrong. Something's not working. Well, so I'll just copy this and I'll try. Oh, I guess I didn't like that. Copy. this, and let's try out this function height. See what it returns. Okay, unable to resolve. Okay, so I should also copy this function then. Yeah. It returns 4, but it should return... Yeah, because I'm an idiot and I'm returning... I should be subtracting the y values, not the x values. That's the... So yeah, that's my bad. Let's exit and let's run our tests now. And let's hope it works. Okay, 116 checks failed, so we have to assume we did something right. So width. Okay, so I can just copy this. No shame in that. And copy it in width. And actually just substitute this. Okay. So we managed to somehow figure it out. And then we have to write if the function square, that returns true if rectangle is square and otherwise false. So we can actually help ourselves with the width and height function that we just declared. So maybe I should... So let's write our if. So so if our rectangle, so if equals height of the rectangle, then and if also the width of the rectangle is the same, then true, false. Like this, but I don't know if this is gonna work. Let's try. Now let's just run our tests like this. So let's see. Oh, we actually passed. 103 checks failed. I mean, only 103. So let's see if we actually have anything left. No, we got it right the first time. Nice. Okay, moving on. Write the function area rectangle that returns the area of a given rectangle. So how do we calculate the area of the rectangle? Let's see if I remember. We just multiply the width and the height. Right. Hope I'm not confusing anything, but I'll just copy this. Yep, no. So this, and I'll just substitute the double equal sign for a multiply sign, and that should be it. Okay, and oh, this one looks confusing. I see, I'm not gonna like this one. So write the function contains point rectangle that takes a rectangle and a point that returns true if rectangle contains point and otherwise false. Remember that you can give multiple parameters to this. So yeah, I think I'm just gonna skip this too because they seem overly mathematical, and I think I'm gonna be stuck for a while if I try and solve them. So I guess I'll just go over to maps. So let's see what maps have in store for us. So I'll just run our tests one last time to see if we have solved anything. We have less than 100 checks failed. So where a vector associates integers to values, a map is not restricted to integer keys. So you can use any kind of value as a key. So it's key value pairs. Okay, no, only 97 checks failed, so we had 6 of them correct, which is great. Right, so maps are written with curly brackets like this, and the map is indexed also with the get function. Okay, so in idiomatic Clojure programs, the keys of a map are often keywords. Keywords are a convenient way of naming keys for values in associative collections, such as maps. So keys are this, they are preceding with a colon. Okay. When used as a function and given collection, a keyword looks itself up in the collection and returns the value associated with it. Count can be used to find out the amount of elements in a collection. Okay, let's define some authors. Okay, write a function title length book that counts the length of the book's title. Counts the length of the book's title. So yeah, so we should, yeah, so I'll have to find out what function there is for string length Clojure. So this is the title length, okay, and we get a book into it. So we basically get a map with a key title and the name and a vector of authors, I guess. So, a book. Oh, so if we do count on a string, we get the length of a string. Okay, so this eases up things for us. So if we do get book title, and if we call our count function on that, we should get the result we want. Okay, let's run our tests. See if we have liftoff. '94, so I think we got some of them correctly, but I guess not all of them, so I didn't do this. Contains point, contains rectangle, because they were boring. Okay, so I guess we implemented this correctly. Next, we have to, let's see, author count. That returns the amount of authors that a given book has. So I think that's, we're just gonna copy this, and we're not gonna be counting the titles, but we're gonna be the authors. So hope I spelled that correctly. I guess I did. Okay, moving on. Exercise 12. Write the function multiple authors that returns true if the book has multiple authors. So if our author count of the book is greater than 1, we should return true. So let's try this. So if another, no author count, no. Count of book is greater than 1, so we should have another pair of parentheses. So if I guess, yeah, if author count book is greater than 1, we should return true, otherwise false. Okay, let's try and run our tests yet again. And we get an error. So, oh, I think I forgot. Yep, I forgot the parentheses. Okay, now only 88 checks failed. Great. We must be doing something correctly. So, adding values to a map. So we do, I think this is associate, a map, a key, and a value. Okay, sets the value of a key in a map to be a value. So, but how do we add some information to a book? We associate cities, awards with this. Okay, so in exercise 13, we use associate and conj to write the function add author book new author that takes a book and an author as a parameter and adds author to book authors. So they're giving us a little hint that we should use let to avoid pain. Okay. Now I'll try and take their advice. So in the function add author, we will get a an existing map. So I guess I should use let like this, and I should do, so if I do authors, it will be book authors, and then I can do this. I can associate okay, so I can associate this with the book, no, with the authors, and I can append, I guess, the new author. Guess the author complete doesn't work. I don't know. Maybe this should work, I guess. Whoa. We actually didn't get any of them right. So well, I don't know. Well, it is getting pretty late here from where I am, so I'll be getting to sleep soon. So thank you for watching. I'll continue this lesson some other time, hopefully soon. I hope you guys have learned or will learn something from this if you're going to be watching this some other time. And thank you for watching.